epic story continues to astonish us. Its dimensions defy imagination. Its price, thousands of lives. It's the crossroads of the world's economy. To protect it, America has gone to war. It's the superstructure called the Panama Canal. December 20th, 1989. Under cover of darkness, 20,000 American troops invade the tiny Central American nation of Panama. As gunfire shatters the stillness of the night, the invaders pursue their prey. General Manuel Noriega, Panama's ruthless dictator and a suspected drug trafficker. 4 days later, Noriega surrenders. The United States declares victory. But America has not put 20,000 lives at risk simply to arrest one man. Noriega's iron grip on Panama threatened one of the world's most important superstructures. The Panama Canal. The canal was born of a fierce struggle between man and nature. A battle that began at the dawn of the 20th century, when America's greatest engineers took on the biggest challenge of their lives and astonished the world. The Panama Canal links the Atlantic and Pacific Oceans at the Isthmus of Panama. A mere 50 miles wide, narrowest point between North and South America. When a ship enters the canal from the Pacific Ocean, two sets of locks raise at 85 feet above the sea. At this elevation, the ship sails 9 miles through a man-made channel carved from the mountains of the Continental Divide. Then 23 more miles across the second largest man-made lake on Earth. As it nears the Atlantic, another set of locks lowers it to sea level. By sailing through the Panama Canal, a ship saves nearly 30 days. The time it takes to sail around the tip of South America. Yet 5 million years ago, there was no need for a Panama Canal. The Atlantic and Pacific Oceans freely flowed between North and South America. Then, about 2 million years ago, the ocean floor erupted. 50 miles of volcanic rock arose between the seas. The Isthmus of Panama was born. Eons later, men dreamed of reopening the ancient path between the oceans. Digging 50 miles seemed seductively easy. But in Panama, it wasn't.
The Isthmus of Panama was one of the most difficult sites to dig a canal in the world. It was geologically unstable. It had mountainsides that tended to slip. It was seismically active, and it still is. It has a huge, almost impenetrable jungle covering it, and enormously jumbled varieties of stone and terrain.
At the end of the 19th century, men learned just how formidable a foe the Isthmus of Panama could be. In 1881, France undertook the world's first attempt to dig a Panama Canal. Confidence was high, and with good reason. In charge was one of the greatest entrepreneurs of his age, Ferdinand de Lesseps. It was de Lesseps who, in 1869 years, 22,000 members of the French Canal Company died of disease. The horrific death toll was matched by financial hemorrhaging. Ferdinand de Lesseps poured $287 million into his canal project and went bankrupt. It was the greatest financial disaster of the 19th century. In 1903, the exhausted French gave up and sold their Panama excavations to a young nation which had just proven its engineering prowess by taming a continent. The United States had the hubris to believe that it could succeed where the French had failed. Many wondered if it could. But the Americans understood something the French had not. To dig its canal, America would begin not with shovels, but with test tubes. A doctor, not an engineer, would lead the way. U.S. Army physician Colonel William C. Gorgas arrived in Panama in 1904. Gorgas was a controversial figure. Many dismissed his unorthodox methods of controlling disease. But these methods had worked brilliantly in Cuba after the Spanish-American War. In Panama, Gorgas assembled his weapons: 3,000 garbage cans, 4,000 buckets, 1,000 brooms, 5,000 pounds of soap, and 120 tons of insecticide. He sent battalions of workers into the streets and the swamps and the jungles of Panama with orders to hit the mosquitoes wherever they lived. Draining puddles and other mosquito breeding grounds, Gorgas's army sprayed thousands of gallons of oil across ponds and swamps, killing the insect's larvae. Fumigating entire towns again and again. The cleanup took a year and a half, but by Christmas 1906, yellow fever and malaria had been virtually eliminated. To this day, the Canal Zone remains the most disease-free strip of tropical landscape on Earth. William C. Gorgas would only be the first of many brilliant men to tackle the challenge of building the Panama Canal. It would be a task that would test the limits of each man's considerable abilities. For even without mosquitoes, Panama remained a formidable geological challenge. To dig their canal, American engineers mounted the biggest and most expensive peacetime endeavor in history. Again and again, they confronted seemingly insurmountable difficulties, inventing new and ingenious ways to overcome them. In 1992, Panama Canal engineers began a massive 10-year excavation project. They will dig and blast 40 million cubic yards of earth, widening the canal channel so today's gigantic cargo vessels can pass one another in its narrowest parts. It's the latest chapter in an engineering saga which began at the dawn of the 20th century. When the Americans began their canal in 1904, engineers laid out an ambitious master plan that would take 10 years to complete. That plan called for building 3 gigantic sets of locks, one on the Atlantic and 2 on the Pacific. To supply the canal with its water, engineers would need to dam the Chagres, the largest river in central Panama. The lake created by the dam would make it unnecessary to dig a canal all the way across Panama, because ships could sail some 23 miles across the lake. But between the lake and the Pacific locks, Panama's rugged backbone would have to be tackled with shovel and pick. This was the Continental Divide, an unbroken chain of mountains stretching from the Rockies in North America to the Andes in the south. Here, the canal builders would face their first challenge: digging a ditch 9 miles long, 300 feet wide, and 350 feet deep. It would not be easy. The French had tried to pierce this formidable barrier and failed.
The problem was that you didn't have stable hillsides. They looked like rock, but they were so badly fissured and layered in this direction that they kept on slipping. Every time you'd cut something, it's like digging a foundation for a house in mud.
To battle the Continental Divide, America sent an unlikely champion. His name was John Stevens. Stevens had never built a canal. He was a railroad man, famous for laying track and blasting tunnels where no one else could. When he arrived in Panama in 1905, he was 52 years old and had built over 1,000 miles of railroad in the United States. As much as any man alive. But could a railroad man dig the world's toughest canal? John Stevens pondered the abandoned French excavations, a shallow ditch called the Culebra Cut. His railroader's mind grasped a crucial fact which the French hadn't. The key to conquering Culebra Cut wasn't excavation, it was transportation.
One of the biggest technological challenges in completing the Panama Canal was what today would probably be called construction management and systems engineering. How to move all of the millions of cubic feet of material that were being excavated, because you can't just dig dirt out, you've got to do something with it. And in order to do something with that magnitude of dirt, you have to have a rail system, a transportation system that is very sophisticated and very adaptable.
Under John Stevens, the 50-mile wide Isthmus of Panama was soon laced with over 450 miles of track, and trains moving dirt, men and supplies with relentless efficiency. As dirt-laden flat cars raced away to dumping sites, a steady supply of empties arrived, ready for steam shovels to fill. But one difficulty remained: how to unload millions of cubic yards of earth. Finding no existing solutions, the Americans simply invented one. A 3-ton steel plow pulled by a powerful winch along the length of a dirt train. In 10 minutes, this ingenious device unloaded more earth than men with shovels could remove in hours. But John Stevens didn't stay to execute his brilliant plan of attack. As soon as he had organized the canal excavations, the headstrong railroader abruptly quit.
He basically said that the difficult work was in the organization and the design, and that the construction itself was no big deal. And once it became nothing more than just a big construction project, he went elsewhere. He went off to Russia to find new challenges.
Stevens' departure infuriated President Theodore Roosevelt. The president turned the job of digging the canal over to Army Colonel George W. Goethals. Said Roosevelt, "He can't quit unless I order him to." Second in his class at West Point, Goethals had distinguished himself in the Army Corps of Engineers. He would use his absolute authority to weld America's canal diggers into a perfectly disciplined human machine.
He immediately put the whole canal zone under martial law and therefore could decree what had to occur. He didn't have to convince. He didn't have to argue.
In 1908, Goethals decreed that the canal channel would be a full 50% wider than Stevens had planned it. Once again, men and machines assaulted the Culebra Cut. Leading the attack were 68 of the biggest earth-moving machines ever built. Giant 95-ton steam shovels made by the Milwaukee firm of Bucyrus. Each of these iron leviathans could scoop up 8 tons of dirt, more than 3 times the capacity of the steam shovels used by the French. The gigantic shovels dug day and night into the Continental Divide, filling a carload of dirt every few minutes. And day after day, the explosions never ceased. 400,000 pounds of dynamite and 800 blasts every month. But the Panamanian soil would not yield to progress without a bitter fight. Huge landslides engulfed equipment and mangled railroad track. In minutes, months of digging disappeared. Miraculously, landslides killed only a few of the 6,000 men working in the Culebra Cut. Dynamite was a different story. The blasting crews were mostly black laborers recruited from Caribbean islands. They did the most dangerous work of all. No one was sure how much dynamite was needed to blast the cut. Every explosion was a matter of trial and error. When there was an error, men paid with their lives. In the worst single accident, 23 men were killed when a massive dynamite charge went off prematurely. A worker from the West Indies recalled, "The flesh of men flew through the air like birds." The Culebra Cut took 9 years to complete, longer than any other phase of the canal's construction. But the battle between man and the isthmus continues to this day. Today's canal engineers have new weapons in their war against the ever-shifting Earth. Using satellites and global positioning systems, they track Earth movements with pinpoint precision. But predicting landslides is not the same as preventing them. Engineers doubt that their battle with Panama will ever end. Nature has thrown many obstacles in the canal's path. Culebra Cut was only the first. Conquering these challenges would make engineering history. When American engineers began digging in Panama, they had to decide whether to build a sea level or a lock canal. Because it gets its water from the ocean, a sea level canal must be as deep as sea level. But in the mountains of Panama, sea level is over 500 feet deep. So the Americans rejected the French idea of digging to sea level. They planned to use locks to raise ships 85 feet above the sea. But building a lock canal created a new problem to be solved. In theory, the locks would need immensely powerful pumps to raise water in ships 85 feet against the force of gravity. But the canal builders had no intention of struggling against gravity. They decided to make gravity work for them.
The most brilliant aspect of the design of the locks are all the water that flows into them and out of them is basically gravity flow, which means that they don't need pumps.
To exploit the force of downward flowing water, canal engineers first had to capture it. In Panama, that was easier said than done. Since time immemorial, tropical downpours have soaked the Isthmus of Panama. Over 10 feet of rain can fall in a single year. Bloated by this immense rainfall, the Chagres River once roared unrestrained across central Panama, from the mountains to the sea, wreaking havoc with its devastating floods. Engineers knew that there could be no Panama Canal until they had tamed the Chagres. They calculated that to control the raging river, they would have to build an earthen dam 100 feet high and 1.5 miles wide, the largest dam of its time. It was a bold design and highly controversial. 17 years earlier, in 1889, one of America's largest earthen dams had collapsed after heavy rains. Moving with the force of Niagara Falls, a 40-foot wall of water swept through the nearby city of Johnstown, Pennsylvania. 2,000 people drowned. Johnstown was annihilated. Fearing another Johnstown, some Americans questioned the wisdom of building the world's largest earthen dam in a country plagued by torrential rains. But canal engineers insisted that their dam would hold. Begun in 1906, Gatun Dam was finished in 1913. Behind its massive wall, the Chagres spread out and drowned 164 square miles of jungle, creating Gatun Lake, at the time, the largest man-made lake in the world. 23 miles long, the lake provided nearly half the length of the canal and gave the locks the immense amount of water they needed to operate.
The Chagres River was really the lifeblood of the whole canal, and it still is today. It provides the water for the whole system, bringing it in at the summit of the canal and guiding it down through the locks until it flows into the oceans.
Because Gatun Lake is 85 feet above sea level, the force of gravity propels its water downhill toward the sea. But the canal's three sets of locks, Gatun locks on the Atlantic, Pedro Miguel and Miraflores on the Pacific, act like plugs in a gigantic bathtub, preventing the lake's trillions of gallons of water from reaching sea level. To raise and lower vessels, the lock operators need only to open and close a series of valves. Water seeking sea level flows into or out of the chambers, raising or lowering ships as it goes. It takes 26 million gallons of water to raise one ship, and another 26 million to lower it. Enough water to meet the needs of a large city for 2 days. To handle this enormous amount of water and accommodate the biggest ships afloat, canal engineers would design the largest concrete structures of their time, so massive that no one was sure they could be built. The Panama Canal's locks are so well designed that today's enormous ships can still travel safely through them with only inches to spare. Before any ship ventures into a lock, canal workers tether it to 4 electric locomotives called mules, which travel on either side of the lock on a high-voltage rail. As the ship moves through the lock, a canal pilot on board tells the mule drivers when to reel in or let out cable. Like fishermen playing an enormous marlin, the locomotives keep the ship from hitting the lock walls. It's a system that works as well today as it did in 1909, when canal engineers designed the lock chambers specifically to fit the 2 biggest ships in the world. One of those ships was the brand new battleship Pennsylvania, 97 feet wide and 600 feet long. The other was a British luxury liner in her first days of construction. When finished, she would be 883 feet long and 93 feet wide, the biggest passenger ship afloat. Although the locks were designed for her, she never sailed through the Panama Canal. Her name, RMS Titanic. To accommodate the Titanic, the lock chambers would have to be the largest concrete structures in history, each one 110 feet wide and 81 feet tall, higher than a 6-story building. Even today, if stood on its end, a single lock would be the 4th tallest structure on the Manhattan skyline, topped only by the Empire State and Chrysler buildings and the World Trade Center. Only when the locks are drained for repairs can we appreciate their awesome dimensions and understand why those who witnessed their construction compared them to great cathedrals. Never had concrete been poured on such a massive scale. No one was absolutely sure that it could.
The problem with casting concrete in massive amounts is that concrete is an exothermic material. In other words, it gives off heat as it hardens. So the hotter it gets, the more danger there is for the material to crack. And the more volume you have, the more dangerous it gets for things to crack too.
Engineers stretched steel cable between giant movable towers. From the cable hung enormous buckets, each holding 6 tons of freshly mixed concrete. The towers traveled back and forth over the building site, pouring concrete as they went.
The cable cranes were made of 2 very large towers mounted on tracks that could travel along the axis of the Panama Canal. They transported the dirt away, they transported the concrete in. They were very flexible because they could move in 3 dimensions. They could move along the canal axis and across the canal at the same time.
In 2 years using this system, the canal builders poured 4.5 million cubic yards of concrete, a volume equal to building a solid wall 8 feet thick, 12 feet high, and nearly 300 miles long. Today, computers control concrete pouring, but we still build huge concrete structures with the techniques and equipment invented for the Panama Canal. The lock designers topped their concrete pouring triumph with yet another dazzling innovation.
Electricity was a brand new energy form. Edison had built the first electric generating plant in 1881, and this was just about 20 to 30 years after that. I don't think that electricity had been used on a building site in quite that extent before.
Unlike steam power, electricity was instant and precise. With a touch of a button, it turned on or off. In the blinking of an eye, it traveled through long wires to start compact motors that drove immense machines. Huge turbines turned by the force of the Chagres River powered 1,500 electric motors which ran the locks of the Panama Canal. An industrial world that ran on steam and animal muscle was deeply impressed. The Panama Canal showed what the new electric power could do. With concrete poured and electricity in place, only one challenge remained for the lock builders: the chamber gates. These gates had to be strong enough to hold back millions of gallons of water. To fit the world's largest lock chambers, they had to be the biggest lock gates ever built, as tall as 6-story buildings. To remain watertight, the gates needed to open and close with flawless precision. In short, they had to be engineering miracles. Massively strong, yet light as feathers. And they were. On dry land, each lock gate weighs 700 tons. In water, it floats. The buoyant hollow frame makes the gate lighter than water.
This is a very important feature of the design of the lock gates, because this means that the machinery that is necessary to open and close them doesn't have to move a very heavy, massive steel gate, but really only has to move something that is buoyant in the water.
Massive steel rods open and close each gate. Moving the rods are huge gear wheels, 20 feet in diameter. Yet incredibly, the whole system runs on a single 40-horsepower electric motor, no more powerful than a motorcycle engine. When the gates were finished, engineers tried opening and closing them in the dry lock chambers at their full weight. One observer noted that each 2 million pound gate swung as easily as an ordinary door. Gravity was the heart of the locks. Electricity was their nervous system. Engineers gave them a brain, the control board. Today, the original control boards built in 1913 still run the locks. Each board is a tabletop model of the entire lock operation. But unlike a real brain, it cannot make mistakes. As lock operators turn its valve handles, letting water in and out of chambers, opening and closing gates, the entire lock operation unfolds in miniature before their eyes. everything must happen in correct sequence. Beneath the board, controls are ingeniously interconnected. No one can throw a switch or turn a valve out of order. If they do, the lock operation stops.
The lock system had a whole series of fail-safe devices. If any piece were left out, if any step were left out in the organization of how to open and shut these gates, how to move ships through the canal, it wouldn't work. It would shut down.
After 4 years of construction, the locks were finished. By then, the Panama Canal was finally nearing completion. But the Panama Canal had been dug as much for strategic military purposes as for commercial shipping reasons. Once finished, it would become one of America's key military assets and one of its most vulnerable targets. On August 15, 1914, the USS Ancon was the first ship to pass through the Panama Canal. A dream hundreds of years old had come to pass. 6 months ahead of schedule and 4% under budget. But it was a dream with a staggering price. In 10 years, the United States spent $352 million to build the Panama Canal, 5 times more than America had spent on the Louisiana Purchase and all other territorial acquisitions combined. The cost in human lives was no less cheap. More than 5,000 American deaths, nearly 25,000 French. 500 lives lost for every mile. The canal builders had carried out one of history's greatest construction projects and could only wonder if their accomplishment would stand the test of time. They could not know that within 50 years, the Panama Canal would face a deadly peril. At the end of World War II, the crew of an American warship in the Pacific were astonished to see what appeared to be a prehistoric monster rising from the deep. In fact, it was a Japanese submarine, 400 feet long, the largest underwater vessel of its time.
The E-400 series submarines are something that the world has never seen since or even before. These were gigantic submarines. They had a displacement of 4,450 tons, which was almost twice the size of the largest American submarine. So this is quite an impressive machine.
Examining the subs, American sailors discovered a strange tube and a long metal track. The Japanese explained that the tube was actually an airplane hangar, ingeniously designed to hold seaplanes called Sirens. Like aeronautical origami, the Sirens literally folded into their tubular homes. Once on the surface, the subs would launch their planes by catapulting them off their decks. The top-secret aircraft had been designed to perform only one mission: destroy the Panama Canal. The attack plan called for a fleet of 18 giant subs to launch 10 Siron seaplanes off the Panamanian coast. The plane's bombs and torpedoes would hit the canal's weakest points, Gatun Dam and the lock gates. With its dam and gates destroyed, the canal would have drained like an unplugged bathtub, crippling America's ability to move men and ships between two theaters of war. But in the early days of the war, aware of the canal's vulnerability, the U.S. military put into action a secret plan of its own. 100 feet under the locks, a maze of tunnels led to Special Items Project 7, SIP-7 for short. SIP-7 was two enormous hydraulic jacks, each weighing 100 tons, supporting a massive slab of steel hidden underground. This film offers a rare glimpse of SIP-7 in action. Pushed upward by the underground jacks, the huge steel dam rises in a lock, capable of holding back trillions of gallons of water if bombs ever shattered the lock gates. World War II ended before Japan could launch its attack against the Panama Canal. Instead, its giant subs ended up as target practice for the U.S. Navy. Today, the National Air and Space Museum in Washington, D.C. is restoring the last of the Panama Canal bombers.
The Ciron aircraft are the only submarine-based airplanes ever designed and put in operation that were intended as an offensive weapon. The Ciron that we have here in this museum is the only clue left in the world of this weapon system. And we're very proud to have this because of the threat that it did show against the Panama Canal and what could have been done.
At the close of the 20th century, much has changed at the Panama Canal. The technology of the future works side by side with the innovations of the past.
What's the ship doing? He's going to hit us. Oh, nothing we can do here, Captain. We'll do it.
Veteran canal pilots use state-of-the-art computer simulations to teach trainees how to avoid
It's very
catastrophe.
important because you have to keep in mind the hydrodynamic effects, the interaction between the two ships.
Today, the biggest ships using the canal are called Panamax vessels. Panamax ships are over 950 feet long and over 100 feet wide. The lock chambers are 1,000 feet long and 110 feet wide. There's literally no room for error.
You do a good job entering the locks, and you can see the face of the master right away with a big smile. And if you don't, then you see him looking the other way, and that's perhaps your biggest punishment.
The world is changing too, beyond anything the canal builders could have imagined. The largest of today's supertankers and aircraft carriers are too big for the locks. There's talk of building high-speed railroads across Central America to compete with the canal. But as the year 2000 approaches and the canal passes from American to Panamanian ownership, this superstructure that once astonished the world continues to serve it well. Since the canal opened in 1914, nearly 800,000 ships have passed through it, carrying over 5 billion tons of cargo. Oil, wheat, computers, automobiles, and vacationers flow perpetually through its 50-mile channel. 15,000 ships a year, 24 hours a day, 7 days a week, 365 days a year. As the 20th century ends, no one expects the Panama Canal to fade into history.
God, I tell you, I admire those people who build this thing. Sometimes you go through the canal and you're concentrated on the job and you don't think about it. But then once in a while, you have a passenger, for example, on a ship that asks you something about the canal. And then you start talking about it, and then you look at one of the hills, and then you feel this incredible admiration for these people.
Here, nearly 100 years ago, human beings took on one of nature's greatest challenges and won. Whatever its future holds, the Panama Canal will always be a monument to that victory. It will forever commemorate the genius, spirit, and raw determination which triumphed so decisively over such incredible odds.